When experimenting with external memory systems, it soon becomes necessary to provide some sort of read-only memory. Stay tuned as today I'll be wiring up an Eeprom programmer using the Parallax Propeller Microcontroller and the 28C16 2K x 8 Eeprom. Hello and welcome to 100 Random Tasks. I'm your host, Philip Lett, and if you like what you see here, please give us a like and leave a comment. And subscribe if you want to be notified when more videos are uploaded, and it would really help the channel. Up until now, the Create Your Own CPU series has used just a small amount of RAM and no ROM. But hand-loading each byte into RAM using dip switches is tedious at best, and time-consuming if more than a few bytes long. Now it's to the point that it's necessary to add some ROM from now on, and having a way to program that ROM is also needed. Small dip-friendly ROMs are becoming hard to come by on the usual channels, but I did find these Eeproms from AliExpress and picked up a bunch. These are the Dash 20 models, which has a 200 nanosecond access time and 10 millisecond write time. Not the quickest, but sufficient for our purposes. So how do we connect these together? The Propeller has 32 I/O lines, and we can connect the Eeprom to the prop how we wish, excluding P28 to P31. As they will be used for the UART and the prop serial Eeprom. You can see that I've set D0 to D7 to P16 to 23. A0 to 10 is connected to P0 to P10. The active low write enable to pin 27, active low output enable to pin 26, and the active low chip select to ground. You'll also see that I have a 0.1 UF bypass cap from VCC to ground. With that layout, the software needs to be written. I won't go into a line-by-line detail, but I will explain the operation. The Propeller spin code is easy to understand if you aren't familiar, and I'll be adding a post on my website where you can get this spin code for yourself, and I'll add a link in the description when it's available. Basically, the program begins by setting up the I/O pin directions and starting levels, followed by starting the serial connection. Then, it calculates the number of bytes to be written, and checks that it is not more than the Eeprom size, throwing an error if it does. Then it erases the chip, writes and verifies the data, reads and displays the first 16 bytes in the Eeprom, and finally ends the program. The write data function takes the pointer to the data to be written, the number of bytes to write, and the starting address in the Eeprom where to start writing the data. The entire program uses bit banging, and could be sped up by using assembly, but for the small size of the Eeprom, the time it takes to write is low, so writing code in spin is sufficient. Basically, for each byte written, it sets up the address, then the data, pulses the write enable, and waits 10 milliseconds for the write to finish. Once done, it verifies the written data by setting the output enable low. Then for each byte, it sets up the address, reads the value from the Eeprom, compares it to what it should be, and throws an error if it is off, and then halts. The read data function takes the start address in the Eeprom and the number of bytes to read, and displays them on the terminal with 16 bytes per line. The erase chip function does the same thing as the write function, except that it writes FF to every location and verifies it, throwing an error if necessary. Finally, at the bottom is the data to be written, starting at the label data and finishing at the label data end. With that quick overview done, I'll go ahead and wire it up. I'm using a Propeller dev board of my own design for this, But you don't need all this extra stuff for a programmer. You can just use the demo circuit in the Parallax Education Kit PDF, which only needs the propeller and a USB to serial converter. Since programming the Eeprom is a one-shot deal, you don't even need the serial Eeprom that connects to the propeller, and you can just download and run it from RAM. You can use many other micros for Eeprom programming using a similar method, and if your chosen micro doesn't have enough free I/O pins, you can use a serial in parallel out shift register or an SPI I/O expander to make up the shortfall, albeit with a little additional programming needed. Ben Eater has a great example video of this using an Arduino. The hardware is ready to go, the program is written, and some sample data created. Let's test it out and see how it works. I'll go ahead and load the RAM of the prop. With that loaded, it runs automatically and is now waiting for a key press in the terminal to start. I just have to enable it and press any key to start, and we'll see it in action. First it erases the chip, then it writes the data. Finally, it reads the first 16 bytes and displays it. You can see that it matches the data to be written. I know that there are a multitude of options when programming an Eeprom, but I hope that this video gives you another possible method, and now I'm ready to start on the next video for the CPU series. So don't forget to hit that subscribe button to get notified when I upload new videos, and it really helps the channel. If you're already a subscriber, thank you. Your support means a lot. And if you like what I do here, consider becoming a patron to help me make more great content for you to enjoy. Thanks for watching. See you next time.